Hey everybody, this is Brad Dyke reaching out to you to say hi. And today we are going to talk about something really neat, something you can do and fairly simply, and that is load balancing. That's right, look at all those ports. But what if you could make all four of these 1 gig ports as a single connection through a virtual NIC? We call this ALB, Adaptive Load Balancing. And load balancing is the principal technology we're talking about here today. Now, one of my fans, I call him 0001 because he's written his name out in binary and I'm not taking the time to figure that out. So I'll just call him 0001. Had a lot of good questions about this and it's confusing. That was the thing. And as I was walking through this process in my head myself, I kind of found it was probably worthwhile to do load balancing in two different ways. And then as the more I thought about it, the more I realized no, actually, no. I need to build on top of each type of way, that's the secret, of how we use load balancing. And that's the key detail here. Let me show you what I mean. Okay, so here is a switch, a basic switch. It's not complicated, it's very easy, it's fully grounded. That's the right kind of network switch, by the way, to have. Is always the switch that has fully grounded functionality. And then right here we have a common, usually a dual port or a 4-port, and in this case it's a 4-port, server class NIC. Now, with these particular configurations, we're going to build on the foundation of load balancing. So here is the 4-port NIC we're talking about. This is very common. They cost about 15 bucks on eBay, and you can have a whole bunch of them in a server. Usually, if it's like a Dell server or an HP server, they'll have 2 or 4 PQF on the logic board itself up front, and then you just stick another one of these in and you have yourself 2 potential pathways for up to 4 ports each, one for your front-end load balancing for your services and one for your backup processes, right? That's a pretty cool thing. Now, understand that when you duplex network ports, that means you're going to bring them together to do both reading and writing at the same time. Remember that a NIC has its limitations, a single NIC. And to get a 1 gig bandwidth and you're doing a lot of reading and writing, you're sharing the 1 gig bandwidth. Not the case when you have 2 ports involved. One can act as the reader and one can act as the writer. Hence, it gives you both pathways of 1 gigabit each, or we call full 1 gigabit duplex. Now, when you have 4 of these in use, that gives you 2 gigabit full duplex, opposed to 1 standard shared 1 gigabit connection. That's load balancing. How is it done? Very simple. It's done by the operating system. When you install the card itself, you will have software from the manufacturer. Let's say in this case, this is a QLogic card, but Intel cards are the same way, HP cards and so on. Inside the software setup for the driver, you can build what we call teams. And all a team is basically taking ports, 1 port and more, not just one, but you're creating multiple ports and you put them into a team, okay? Now, the port teaming will then be allowed to be associated to a virtual front end. We would call that a virtual NIC, or a network interface card, an IC. Now, that process has some minor changes or minor differences on it by manufacturer, but principally the standing is still the same. Somehow you'll team up a set of network ports to formulate a virtual NIC which will then go to a network switch. Now, here's the bad news. When you do load balancing to a switch, you can't take 2 ports and go to one switch and 2 ports to go to another switch, because you've separated the segmentation of how the teaming process would work. It would break the NIC. You'd only get half your bandwidth and it'd be on the primary, but the other side would then cause what we call a storming effect and really messed up both switches in the equation. So always plug all of your connections in a single team to a single switch front end. And in this case, so this simple 8-port switch, you could connect 4 ports to here, and then at that point stage, you would have to move it up into the upper pipe. So for instance, in this switch, this is a dumb switch, so this doesn't do very good. But if you had a backup server with 4 port connections teaming and your primary server was on the front end and you wanted this for your backup so you had extremely fast backups, this would work. But let's get a little bit more advanced. Let's say that you're working with a 48 port switch, right? And you have in that 48 port switch 4 or let's say 2 fiber optic uplinks. And let's say they're 10 gigabit uplinks. Okay. So if I had 3 or 4 or 5 servers teaming, that's a lot of firepower, but my switch's backend can take it. And since I decided to load balance on the switch, I can do load balancing of sorts between switches. So yeah. So if I take 2 10 gig ports to create a full duplex 10 gigabit pipe that's redundant and failover, cool. Then if I have a business and I have a top tier switch, let's say it's your server switch, which is connected to the ISP, we'll talk about that later, and then it's got 2 fiber optic cables that come out, and they round robin between 4 building switches that do all the connectivity in the building, and there are 2 connections, and then there's spanning trees is what we call this. They do spanning trees between the switches, sharing 2 pathways. 2 pathways basically means I'm building my infrastructure with 2 alternate functional pathways. In other words, if my front end of my connection breaks, no problem. I'll go down to the bottom end of the switch and go the other way to get to my core server switch. This is called spanning tree. This is an upgrade from simply doing a NIC. Now we're talking switch to switch. 2 connections that are providing 2 pathways, primary and a secondary, also referred to as PIIO mode. What is the primary interface op pathway? The PIIO mode is going to say, well, this connection is the priority one, and this is my backup path. And this also allows you, when there's nothing wrong with either one, to do full duplex. Pretty cool, right? So first, we started out with a couple of servers with 4 1 gig connections formed as a team to create both redundant pathways, all 4 ports, and a combination of bandwidths to give us 2 gigabit full duplex. Then we're going up to the switch, and from the switch to switch, we use spanning tree technology, which is also load balancing and duplexing, to basically provide redundant pathways and faster bandwidths for communication. Now, here's what gets a little tricky. When you have a device going to a switch, or when you have a switch talking to another switch or a series of switches, you have what's called failovers. Now, let me explain. It's really easy when you think about it as a card. And this is where it gets difficult. And this is where I said I need to build on this as we discuss it. When you have a NIC, this is the easiest way to do it. And you're going to use all 4 ports for one team. And you have them set up. And if anything happens on this NIC card and one of these ports go down, the card will determine through the team, okay, tag that guy down, alternate route path, fail over. This is important. This is a 4-way pathed load balance, because as long as I have one of these operational, the other 3 could go down. I can fail over. When you're dealing with switches, and you have 2 pathways, we call this X2 failover. In other words, I have 2 pathways. I have an alternate if my primary goes down. When you deal with what's called a corporate core switch setup, you have what's called 4X. And that's where we have connections between 4 separate sets of switches, 2 pairs each, connecting to and all the other switches, and we have 4 alternate pathways for 4 connections. And that's where it gets a little crazy. But don't worry about that. If you're making $100 million and you have a full-blown data center, then think about 4x4 failover models. Fabric SANs, by the way, if you know SANs technology, that's storage area network technology, which is not the same thing as IP-based switching, they are by default always set on 4x4 failover. 4 pathways, for switches or for pathway set switches, and that's for high availability for the storage network, because storage can never fail. It's very important that your SAN be highly redundant. Now, with that being said, the key thing about this is load balancing 101 is to understand that you have your ports and they go to a common interface called a switch, or a switch to switch or core to switch, that you're basically kind of doing it always from a source to a common bandwidth. That's normal. Load balancing 2.0. This gets interesting. There are two types of load balancing when it comes to the world into your environment. Most people will have what they call a core switch. And the core switch will have one connection that goes to an internet service provider. This is where you're getting your outbound connectivity to the world. Now, all of us poor people in our poor little home labs have usually just a single ISP providing us our total bandwidth. But if anything happens to that ISP, I'm down, right? Well, for a business, that's not profitable. So what's being done is that you will have basically a different kind of strategy where you will have two ISP connections, Spectrum and Verizon, or MetroNet and Sprint, and so on and so on. Your provider may be some other generic baseline provider, but what they do is, let's say you get two 500 meg connections, that's 500 megabit connections, right? And they will come in, but you set them up as what we call a failover connection. Now, why would you set up two ISPs with two 500 meg pipes and only do failover? Cost. So basically what I mean by cost is when you get your ISP connection, right, and that cable comes in, the one that has you the primary connection, you're going to be using all 500 megabits constantly. And that costs money, right? But when your second connection comes in, Mr. Blue provider comes in, you can SPLA that agreement. SPLA means ramp up and go down as needed. So you might have a $200 bill for a dedicated 500 megabit uplink with Sprint that you pay every month. And you have a SPLA burstable 500 meg connection by your second provider. And it's basically there is a redundant backup. And one will cost you $100 or $200. And dedicated connections, by the way, are much more functional than segmented connections like homes get. And then you might have a very low cost, let's say a $50 cost for the second ISP connection. This is the small business model for redundant load balanced interface. So we flipped it completely upside down. Instead of having a single machine getting multiple pipes to the switch to do really fast communication, we now have two different NICs or network connections coming together to act like one. It's tricky. The second form of doing this kind of distribution is known as BGP. And BGP basically is big gigabit port or bandwidth. And this is the next level of load balancing, and it's adaptive load balancing. And that's what adaptive load balancing means. It means not only do I give you a failover, but I can merge these to give me a bigger pipe. But BGP is a little bit more difficult, and what ends up happening is this 8-port side of this switch could be literally nothing but ISP providers, different ones. And they all have what's called a common configuration setup, and they have the common denominational values for DNS and route pathways. That's very important because you're not going to get it to work correctly if the ISP connections don't know to properly route together. They all independently look at that source, maybe a route or maybe a DNS server or whatever, but they all look at the same basic pools of resources. This allows you to have what we call customer-based load balancing. So what would you use this for? The first one makes sense. Having a redundant ISP connection makes good sense. I mean, we're a small business, but let's say you're a web business. And if you're a web business, that means you have web servers. And if you have web servers, that means you're going to be getting a lot of web users. Now it's starting to make sense. Why? Well, because when ISPs connect up to your, let's say, an F5 series load balancer switch, which is a very common switch, the ISPs bring to the table their amount of connectivity sessions they can support. So let's say you plug in one connection and it gives you 10,000 concurrent sessions for access. And usually one user could take 1 to 3 sessions. That's not many people, right? That's about 3,500 people at any given time. But you start connecting other ISPs into this and it gives you 50,000, 60,000, 70, 80,000 sessions. Now we're able to take a lot of traffic, funnel it in, and if on the front end of your switch, your Force 5 switch, makes a connection on a dual 10 gig connection into the core switch, now you're bringing some massive amount of session concurrencies out there that are properly segmented in their own VLAN that's going to hit the front end of your web servers and your web services, and you are able to do what you need to do. That's it, in a nutshell. It sounds complicated, but it's not. It's actually quite the opposite. Load balancing for a server is everybody comes from one source. Load balancing from your customers come from multiple ISP providers. And with that being said, that's it. That's either load balancing, that means 2 ports backing each other up for pathway, or adaptive load balancing, which means you got 2 ports that'll work together as a single port, but they're also failover, but you'll lose 50% of your bandwidth when that happens. And of course, you have adaptive load balancing with more than 2 ports. And the rule applies to either way. It doesn't change. Now, as an IT guy, why does this matter? Well, you know what? I'll tell you why it matters at your server level when you're doing adaptive load balancing within your data center. So for instance, here is a dual NIC team from switch 1 and switch 1 for this guy, but he has to transition, right? This wire has to be removed and refed correctly, or it has to be disconnected with another properly ran cable to meet the requirement. So I plug it. You're not down. Server's doing everything it has to do. There's no need to stop any services or anything like that because your alternate port is taking care of all the traffic. Only a packet or two actually in the first connection that this guy had went away. And then you move and you rebuild your cables, you do whatever you're going to do, and then you put the new cable in. It will reestablish the team and bring it back up without any manual procedure. Unless you're Linux, you might have some issues with Linux because Linux is not as adaptive as Microsoft for this one topic as you would like. So you'd have to kind of make sure that the NIC comes back in properly, or you build in what we call refreshes, where it will say, okay, do I still see NICs? If I don't, it will initiate a refresh to bring the NIC back online and so on. But it requires some configuration. With Microsoft, it doesn't care. It will detect it within a couple of microseconds and it'll come back up, at least from the last few times I've done it. I haven't done it with 2022 yet. But the key detail is, being able to disconnect portions of your interface and continue to work is valuable. And for the IT data guy who's got to do this, whatever cable or whatever they got to install, or somebody says I got to burp my butt and I want all the cables come from the left instead of the right, no problem. All you have to do is move one cable at a time, reposition it, bring it back around, plug it in. It's the same way with ISP providers. When you have multiple pathways of ISPs, and the provider comes in and says, "I've got to take down your front end switch connection, and we've got to do maintenance on it or whatever. They got to replace that little box that provides it. What we call a transceiver box. No biggie. Unplug it, do your thing. I have another connection to the other ISP. It's covering the workload for you." And you're okay, and you never went down, your services are operational and function is good. That one ISP connection is rebuilt and he brings back in the new whatever and rock and roll, redetect it and bring it back online. Switch management would be required for that to make sure that the connection properly syncs. But like for instance, you're working with a Force 5, you'll go through the console to make sure that port redetects correctly and begins to segment the packets like they're supposed to. So, with that being said, this is about logic. I wish I could show you cool pictures of switches and so on, but that's not really what you need to know. What you need to know is the logic. Let me teach you the secret cardinal rule. There are only a few protocols in the IT industry. That's it. There's not a lot. Because of that tiny detail, you don't have a big headache here. And you probably say, what do you mean I don't have a big headache? Well, let me explain. If you master the protocols and not the vendors, you will always be sharp. In other words, master spanning tree and master IP 4.0 or IP 6.0 or both, and every switch that's manufactured, brought to the table, regardless of its connectivity, will allow and follow the same laws that all the other switches have to follow on those protocols. So that's why learning the protocols is more important, being good on them, than being good on any particular switch or server or device and so on. Like DMS, direct memory systems relate to handling memory. You have protocols for hard drives. If you know the protocol for a hard drive, there's only 2 or 3, by the way, you understand what it means to have direct device mapping, and you'll understand why disk arrays work like they do. It doesn't matter who makes them, but if it's SAS, it's pretty cut and dry. If it's SATA, it's pretty cut and dry. And IP NAS is pretty cut and dry. It's 2 protocols, that's it. DMS, IOPLY, and IP. So take the time and just research a little bit about load balancing as a protocol and understand the different levels and potentials you can do with this. You've got LB, which is load balancing. You got ALB, which is adaptive load balancing, and you have spanning tree, and you have BGP, and so on and so on. It's not difficult. I'll try to find a couple of links and I'll put into this video for you that will help point you in the right direction. As for how do you, and I already know this question's coming, so how do you set this up? If you want to do what you want to do and you got a 28 port, you have a 28 port switch, you want to do just this now, here's the answer. Identify your NIC card. Get the correct drivers from the manufacturer for your NIC card. By doing that, and yes, even OEM NICs like Broadcom and so on, they have manufacturer drivers. Inside the manufacturer drivers, if the card is capable of doing this, they will make available to you the ability to create virtual NICs. Look under that. You should see something that says load balance. And you can go in there and set up your NIC card. Everyone does it differently. And sometimes the verbiage is not the same, but the technology and the protocol are always the same. To create a virtual NIC, you need 2 MAC addresses, period, or more. So the bottom line is you do have to do some research. The second bottom line that you need to know, and I know this question is going to come up as well, is when I do load balancing, do I change my MTU? No. You set your NIC cards to the bandwidth at which you're using based on the switch architecture you have. For instance, all my switches run at 9017. Why? I could go higher because my Windows boxes won't allow anything higher than 9017. Linux boxes don't care. So, since I have restrictions on that front end, I'm going to set everything else in my environment to the same. So when I route jumbo packets, 9017 on my MTU is the established norm. You always put your MTU in first before you do anything. And you set your NIC to match the MTU value, so everything in the connectivity model has the same MTU. If you put a little unmanaged switch like this on your network, it will not do it. This is only set for, I think, 1500. It is not much at all. The point is, this is default, and unmanaged switches are not modifiable. So it has to be in a managed switched environment. You can possibly get high bandwidth, but it'll be limited bandwidth on unmanaged switches, like a 24 port or a 16 port switch. Like for instance, you connect your backup server and you connect up your server that has all your data, and you'll probably get pretty decent speed, but you'll only go at the speed of the MTU that the switch can handle. I can't fix that. No one can. It still works. It's not quite as nice. Go to a manageable switch that allows you to adjust the MTUs, and you're in great shape. Oh, and one last thing. I don't care if it's 10 gigabit or 1 gigabit. They all have to be set to the same MTU level. So make sure you set those values. I know some of you guys are starting to get 10 gig switches, and that's great. You might have what we call a front end, back end 10 gig switch. That means you got like 24 ports that are 1 gig, and then you have 4 ports that are 10 gig, so you can do spanning tree up to 4 ports. Fine, there's nothing wrong with that. But please understand that that's what that is. You only have 1 gig connections with a backplane that support basically 24 gigabit, because you have 24 port connections. It'll be a little higher than that, probably like 26 gigabit backplane. And then the 4 10 gigs will work within the 26 gig. So that's not quite right. So it sucks. What it's supposed to be in the industry is 24 1 gig ports, which is 24 gigs plus, about plus or minus 26. And then for the 4 10 gig ports, 40.3 or 40, let's say 43 gigabits added to the 24 25 gigabits for a total of roughly just short of 70 gigabit backplane. That is a good switch. That is a perfect switch. It's the same strategy they do with SAN switches. Everything that has connectivity is one value, not shared. Network switches, especially cheap switches, just because you've got 8 ports here does not mean that the backplane of this switch is 8 gigabit. You know what I'm saying? So, with that being said, I think I've painted a pretty clear picture about how to use load balancing efficiently with the right kind of switching, and also what your potential headaches will be as you're learning how to do this. So with that being said, I hope you like this 0001. I hope this meets what you're looking for, and we'll take it from there. I will see you guys later. God bless and have a great week.